And you can download the IQ sample dataset in the IEEE data port and post-processing code in here. If you're following this link, you can see the download link in the IEEE data port. For example, we download 70 meter height dataset. This is LTE IQ samples. And you can download the post-processing code in MATLAB in this link. You can download the 4 files and download and save it in the same folder. And because the dataset is formatted by SIGINT, if you try to decode the dataset, you need to install the package for the SIGINT using this site, and for the Python you can using this lines. After you download it and unzip the single folder, you can see these files, and if you go inside GPS log, you can see these files in here. And then you can run this Python file using the Python applications. This is the terminal. And in the folder that you save the files, you can use the Python command and run the Python code. The first, I run the SIGINT to CSV to GPS, and it's done. After you've done it, you can see that in the CSV file folder, you can see the file is generated. And you can run the SIGINT to a MAT-IQ Python file. And you can make the SIGINT file to the MATLAB format IQ samples. It takes some time to convert it to the MAT file. After it is done, you can see that MAT file is generated in this folder. This is LTE IQ samples in MAT file format. You need to move CSV file folder, and you also need to move MAT file folder. To run the MATLAB processing code. First, you open the process LTE recording GPS log file. And then this code decoding the IQ samples and generate some RSRP values and RSRQ values. And at the end of this code, it reads GPS log and integrate it to the RSRP and save the MAT file. And if you run the code, if you have the LTE toolbox, you can see this warning error signal sign, and you can go inside and you need to add LTE toolbox folder and then go back to the original file folders. Then you can run the code. If you run the code, it keeps decoding the IQ samples, and it takes really long times if the number of the file is large. after decoding is finished, you can see the map file is generated. The name is plot data 1. And you open another post-processing code and check the UAV height, in this case 17 meter, and change the name of the map file, in this case plot data 1, and you can run this code and generate the plot from the data. The first figure is time versus altitude of the UAVs, and generate the 3D distance versus times during the flights between the base station and UAVs. And then generate RSRP result. This is receive signal strength in time and distance domain, and model it with the two-ray and free space path loss model. After that, you can also generate the plots for the PDF probability density function of the shadowing components and fitting it to the Gaussian and left-screwed Gaussian model. And you can generate the UAV speed versus times from the GPS logs. And you can also generate trajectory of the drones with the RSRP value, the received signal strength. You can see in the 3D domain. You can rotate the figure as well. You can also see the top view of the trajectory. Now we plot the channel estimation and resource grid and correlation peak from the channel estimation procedure. We reopen the post-processing code using LTE toolbox, and we select the single IQ sample to plot those figures. In this case, we select the first IQ samples, and we activate the plotting code and set up the breakpoint and run the code. You can see the channel estimation result and LTE resource grid from the received signal. We can rotate the result as well. This is received signal strength, and you can see the resource grid of the IQ sample. You can clearly see the PSS, SSS, PBCH, and CRS results, CRS locations in the resource grid. And we also plot the correlation peak for the frequency offset correction step. It using the CP repetition, and clearly see the correlation peak from the repeated CPs. There is 7 OFDM symbols, and we can clearly see the 7 different correlation peak from the CP repetitions. This is using for the frequency offset correction. This is how installed Ubuntu in Windows 11. Go to the Windows PowerShell and type the line to install WSL and Ubuntu together. Type the username and password. After restart the computer, you can open the Ubuntu and install necessary app package. First, we update the app and upgrade the app. Then install Python 3 and install pipe for Python 3. Now we can install Signif package. And install any other necessary apps. Now we are ready for run the Signif formatted file. Go to the directory that unzip the Signif file. This is the location of the directory. You can see the files. We will run the Signif to CSV GPS Python file.